First of all, thanks to the organizers for inviting me here and giving me this opportunity to talk to you. Hopefully, the ideas that I'm going to share with you are going to be interesting. I hope to, fulfill your curiosity and answer the questions that might be in your head. Just as a short introduction, I'm currently working at Vestiaire Collective, which is a C2C marketplace for luxury fashion products in Paris. It's actually a global company, but we're kind of in a niche field. So, we have a lot of growth challenges, data challenges, etc. That basically it's my job to work with. Previously, before that, up to February this year, I was working in Alibaba in Singapore, which was quite a interesting opportunity to see how the Chinese data platform works in action, and gave me a lot of lessons that I'm trying to apply now in a much smaller scale in Paris. So the title of the talk is The Perfect Data Platform, in quotes. I added the quotes later. Why? Because I think it's a deliberately paradoxical title, because there's no the perfect data platform, because every company is different, everybody has different different needs, different challenges. So what's really important is not so much to find the one-size-fits-all model, but more to be able to understand how to evaluate what you really need and then be able to find the right solution for it. So this talk, because it's also the first talk of the day and of the conference, we're going to keep it a little bit more light. I'm going to go into some technical topics, but then for those of you who are looking for more or thirsty for more deeper information, we can discuss it later during the Q&A as well. Okay? So just to do a quick audience check, let's just raise our hands. Who of you considers yourself a data scientist in the audience? All right. I think most of the data scientists are probably also in the other talks as well. Data engineering. Who of you considers yourself a data engineer? All right. I see some people raising their hands 2 times. It is, in fact, very close to each other. Who is managing a data team in the audience? All right. Quite a few. Okay. And who of you is planning to create a data platform from scratch? So maybe right now you don't have a data platform and you want to have one in the future. All right. Okay, so just to get a little bit of an understanding, basically this was the challenge that I had in the beginning. So I'm going to share a little bit about the way I kind of thought about this and the way we approached this issue. And so far, it seems like we've found a few successful solutions. So before I begin, I'm just going to kind of ease into the topic with a little kind of mental exercise, not using data as an example, but just to emphasize the idea of scalability and how scalability is an issue and how it becomes an issue inside a company, basically, especially from the technical point of view. So for this, let's imagine that you're a developer and you get a Jira ticket to dig so you're obviously not a software developer, but let's say the ticket is to dig a 1 meter times 1 meter times 1 meter hole in the ground, right? So who of you thinks this is a difficult ticket to solve? Not many, all right? So who thinks it's an easy ticket to solve? Yeah, I think it's quite easy. Depends on let's say it's not complicated ground. Let's say it's sand, right? So probably an easy. Well, okay, sand might be a bit complicated to get the dimensions right. Okay. But in any case, yeah, okay, it's an urgent topic. You get into it, you find a shovel somewhere, and you resolve this issue, right? And then the next day, you again go to the office and you have a new task. And this time it's basically the same task as before, but slightly bigger. So this time it's a 10 meter times 10 meter times 1 meter deep, right? So who of you thinks that this one is a difficult task? Maybe a bit more than last time? Yeah? Maybe 100 times more than last time? Or is it more than 100 times more difficult? Anyway, of course, the project manager says basically the ticket is the same as last time, just slightly bigger, so why don't you just go on with it the same way that you did before? So, okay, you're going to take, obviously, 100 times more time to complete this one, but it's, again, doable. And then you, on the third day, you get to the office, and this time, again, the same one, but this time it's 100 meters times 100 meters times 20 meters deep. So who of you thinks now this is difficult to do? Okay, a bit more than last time. So, but of course, you know, the project manager again says, yeah, I mean, this is the same as what we did before, slightly bigger. Just get on with it with the same approach as you had last time. Right? Yeah, of course, this is the point when this comes into play, which is basically that, you know, the size of the task is getting bigger, and of course, this is not a scientifically calculated graph, but at some point, the difficulty becomes, you know, more and more, and it's approaching a limit, some kind of limit where you cannot fulfill it anymore. But the reality is that it's not like kind of a hard limit. It's not that there's a specific type of or size of the task where you can exactly no longer fulfill it. It's more like a gradual increase of pain, where basically in the beginning you think it's easy, then it starts to become a little bit discomforting. At some point you start to really hate your job. And at some point the whole thing just collapses because you're no longer able to complete it. And again, here, you know, it's relative. Some people will complain earlier, some people will complain later, but clearly, you know, the difficulty is rising. And at some point, you know, somebody has an idea, maybe what we need is a better tool for this task, right? Even though the task looks the same as the previous one, we cannot use the same tools as we had last time to fulfill it, right? So we need to basically do an upgrade, right? So what you do is you reply to the whole team that in order to fulfill this task, we need to you know, get a purchase order approved from finance to buy the excavator. Then we need to select the vendor. Then we need to confirm the investment plan for the excavator, and then we need to train the qualified staff to use the new tool, right? And all of this is going to take 5 to 6 months, right? So what do you think the project manager is going to reply to this? Who's gonna like the idea of, okay, it's going to take 6 months to fulfill this Jira ticket from before? Usually what I saw in companies is that you get something like this. Why don't you just use more shovels, right? Why don't you, I mean, okay, like you did it before, it's bigger, but like you can just do more of the same and you will get the answer. But the reality is that even this approach is not gonna work at some point, right? So at some point you're gonna have to have so many shovels and so many people working on this that you're just not gonna be able to handle it, and you're gonna have to hire a shovel purchasing department and, you know, people managers to actually manage the people who are digging the hole, et cetera, and supervising it, and it just doesn't scale anymore, right? So what's happening is, of course, you know, after some debate, this is not going to go through, and we're going to have to actually upgrade. But what's usually happening is that you get kind of a like cycle like this, right? So you're growing the task, then it becomes impossible to manage, then you upgrade to a new tool, the task becomes more easy to do. Then you have to scale up again. You need to get an even bigger tool, of course, and then you upgrade again, and then it gets easier, and then in the end you buy this thing, which is probably capable of destroying mountains. And so on and so on. So this is kind of like the cycle of pain that how scalability looks like in a company. Yeah, that just brings me to this anecdote that a friend of mine once asked me, who's not working in big data, why is it such a big deal? Why is everybody talking about this right now? I mean, it's just simple stuff. The problem with big data is really that it's big. It's not so much, sometimes it's also like the algorithms and all of the things that you want to do with it, but the problem really is that the solutions that would work on a small scale do not work anymore on the big scale. So that's why we need to do all of this and design algorithms and think about all these things. So yeah, the question always for any data platform is, will it scale? And how will it scale, right? Like at some point, it won't scale anymore. So what will you do then? And that's why what I'm thinking is that the #1 job of any capable data platform is to really make it capable of scaling and capable of migrating when you need to do that, right? So just a simple concept, very oversimplified, is that you have two types of scaling. You can scale vertically or horizontally, either by adding more shovels or by upgrading your tool. And you will need to do both at some point, right? There's no such thing as like infinitely scaling horizontally. So yeah, there's always a trade-off here. So how does that look like? Let's say you have a set of tools. You begin, then you're scaling a little bit horizontally for a while, then you have to do a migration, which costs a lot of money and time, and it's kind of a dead zone for developer capacity. Then you move to a better tool that scales better, and you grow a little bit faster, and then you migrate again, and so on and so on, right? So if you just look at this, it becomes quite intuitive that what you really want is something that can minimize this migration time and make it as easy as possible, and something that can extend basically the areas between the necessary migrations as much as possible. So if you can spend more time scaling horizontally, then at some point, maybe this one will not be necessary and you will just go straight to the next one, right? And this is something that's important to think about when designing the data platform for your company. So okay, now back to basics. I think this one will, come as no surprise to anyone here. But basically what I'm approaching this with is any data platform has three parts. Data needs to come in, then there needs to be some kind of management of the data, some data model, et cetera, and then data needs to go out and it needs to be used. So let's try to find objectives for each component of this. So for the data in, I put two objectives. One is to include all of the data. So why all data? When you're doing a project, let's say that you're devising a new data science algorithm for a particular use case, and you discover that you need a new data source that is not currently in the data platform. It will take you quite a lot of time to include it, right? So really, if you want to design the perfect data platform, it should already include everything that you have, right? So there should be some kind of effort in the beginning to just get everything in. And even if you don't necessarily schedule it to run all the time, it should be very easy to include that, right? So that's design choice, of course. But I've seen that this really shortens the cycle time to developing new things. And for the same reason, also to go as close to real time as possible. Because again, like having a data source and then discovering that you need to schedule it more frequently will add a lot of time to your project. Because then you need to go back to the beginning and go through all the steps. The data model itself has three objectives in this order. The first one is usability. So if the data model is super efficient and super stable, but nobody knows how to use it, there's no point, right? So you want your developers to be able to find the data they need very easily. The other, of course, is stability. So if it's failing, then there will be certain use cases that cannot be covered with this data model. And three, efficiency, which is the last goal, which is, okay, let's try not to make it cost $1 million a day to operate this, right? But then again, it is the third goal. So again, if it would be super efficient but not stable, no point. So good to keep it in mind, but sometimes not the first priority. And then on the data out, this is just basically, let's try to get everybody in the company to benefit from this. So that's kind of as wide as possible. So make the data platform available to as many users as possible, basically, directly, without having to go through another team or something like this. And then utility means that they can actually do what they want with this data platform. Yeah. So I think what you're already getting from this is that I'm really not thinking that much about specific use cases right now, right? So this is more about how do you just make sure that the people who are actually developing the use cases can benefit from this as much as possible, right? So then it's kind of more a platform thinking. So that gets me to my next point, and I'm not going to talk about this much, but I've kind of seen three types of teams, data teams working on a data platform. And the most frequently one, I see this one, where you have basically big teams working on specific use cases, and then a small support team that actually develops the data platform, right? So imagine, maybe you have a recommendation engine and a BI team, analytics, et cetera. They're all working on using the data, and they're kind of serving their customers directly. And then they have a small support team that they can rely on and send tickets to and say, hey, I need this data source or that data source, et cetera. Then in a very large scale, I've seen this one actually work very well, where there's a massive platform team, which is just really focusing on getting the tools out and making the platform as efficient as possible. And then the use case teams can be very small. Because if you have a very powerful toolkit, very powerful data weapons, let's say, then you don't need a lot of operators, right? Because then, even one developer can make something that is extremely scalable and works extremely well just because they have a powerful data platform in their hands, right? Right? So you need maybe fewer people in the use case team, right? So I've seen, for example, then companies move this way. I've seen also companies move this way. So sometimes it actually makes sense to start like this and then move to this one once the platform is developed and capable, because then you can really, move even faster. The benefit of this is also that the team can overall be smaller because if you have a lot of different use cases, you might not have enough people to staff each use case team enough to actually be able to deliver these things. But then, of course, there's the third option, and this is the one that I'm going to focus on, and that I like to focus on, is if you really want to have a very small and agile team, is to try to kind of reduce this block by using as many off-the-shelf technologies as possible, right? And then you basically rely on the platform development capacity of big companies such as Google, Amazon, et cetera, right? So you don't need to reinvent the wheel too much. And you hope that they know what they're doing, right? Usually they do. Yeah. Okay, so let's try to get more specific. Enough of the theory. So very simplified again. What we need to do first is to check our use cases. What do we need? Then we need to make a bunch of design choices. We need to pick the right tools. And every time we have to make a choice, we need to know how to make that choice. And then we need to design the working processes around the tools and around the use cases that we have. Right? And I'm really going to focus a little bit more on the second point here. So, okay, like what do we need? Classic needs analysis for a data team would be, okay, what kind of data do we have? Is it structured, unstructured? Is it images? Is it simple SQL tables, et cetera? What are the sources for our data? Where is it coming from? How do we collect it? How much of it? How will we use that data? Is it for analytics? Is it for data science algorithms, et cetera? And what are the latency requirements? Like, do we need the data to be there every week, every day, every minute, every second, millisecond? I don't know. Okay, so I'm not going to spend too much time on this. You can answer this for your own company. I think you probably already have. So the first thing is, the first kind of component is, if you go back to this, right, is the central piece, right? Like, what do you actually put in here? Usually it's a data warehouse. So why do we even need a data warehouse? If we take a step back, is you basically have two types of databases. You have the databases that are very good for transactional processing. So those are the ones that are usually for computing systems like MySQL or MongoDB, et cetera. Like, you have a lot of different kind of transactional databases that are very good at processing single records, but then kind of fail when you need to do something really major across a lot of records. And you have analytical databases that are the other way around, basically. But then what's also happening right now is that those two, the distinction is getting smaller and smaller. Basically, transactional databases are getting better at computing a large amount of data, and analytical ones are getting faster and faster, and they have smart caching, et cetera. So maybe in the future, one of them will kind of take over the other as well. So it's also something to keep in mind. Maybe in the future, we don't even need a different system for a data warehouse. So, okay, let's say, let's say we say, okay, we need a data warehouse. What do we use? And how do we make the choice? I just picked 3 options that are currently in the market. I don't know, is anybody working at any of these 3 companies? Yeah, which one? Okay. Redshift? Snowflake, anybody using? Yeah? All right. So I'm going to try to stay as neutral as possible. But what I tried to pick is, when we had to make this choice, we also picked between these three companies. There was also the consideration for Microsoft, but then because of some compatibility reasons, we narrowed it down to these three. My main consideration here was how will it scale, again, going back to the previous topic. And then we just did a simple check, right? So, okay, how will it scale? Redshift. Every time you're basically purchasing computing nodes that contain storage and CPU power, right? So if you run out of storage, you need to get more nodes, even though you have enough CPU power, right? So that's kind of a limitation, right? That's kind of like where, you try to basically draw the line where, at which point will I have to move to another system because of this scalability issue, right? So that's the limitation here. On Google BigQuery, the nice thing here is that you don't really have to worry too much about storage because it's decoupled from computing, but you're paying for each query separately based on the number of lines that it's scanning. So if you want to really hit it with a lot of analytical queries, your cost is going to start to go out of control, basically. And then you might need to, again, migrate, right? Because of the cost, basically. Not because of a technical limitation, but really because it's becoming too expensive. And then Snowflake is kind of similar to BigQuery in this sense. The difference is that instead of paying per query, you're paying per computing node. So it's slightly easier to control for the cost, yeah. But then the limitation might be on the slightly higher storage cost, for example, than Google BigQuery in some cases. Yeah, I don't know. Those of you who are using these three systems, or one of these three systems, do you kind of agree with the point on yours? Yeah? Like, for example, for Redshift, did you face this issue that you ran out of storage, but you still had CPU, or vice versa? Yeah? Okay, I see some nods over there. Okay, so yeah, that's basically the infrastructure itself, right? But then, okay, once you have the infrastructure, what do you do with it? So again, like, I'm trying to decouple as much as possible the infrastructure from the kind of logical structure of it, because also, like, I think it's very important to design your systems in a way that they're modular enough to be swapped out with minimal impact. So you need to have really some design on top of the infrastructure itself. I think this one is quite familiar. Most of you probably use something like this. Yeah, so yeah, I think it's quite clear. You sync all the data as is into an operational data store. Then you have kind of a clean data model with a clear naming convention. Something that's easy to use, something that's scalable, and you take into consideration all kinds of like possible ways that your company can expand. Maybe you will have multiple brands, maybe you will have multiple users, etc. So you design it in a way that your naming convention basically won't choke you here. And then these are kind of like, each of your use cases can have their own schema or their own space where they can develop their pipelines without worrying that other people will impact. So if you're giving access to a data platform to users outside of your team, you will probably give them access only to the middle layer, right? You will tell them, okay, this is where the data is. You will not even tell them that this exists in most cases, except maybe to the developers of the system itself. And to this one, you will tell them it exists, but don't use it because it can change at any moment. So you don't want the, let's say, data science team to have to check with analysts if they can change a table or not. They should be able to do that without consulting anyone. Okay? And then on top, you have the consumers, basically. And then sometimes in the middle, you have also some kind of a staging layer where you make the data available to users for these use cases where the data warehouse itself is not performant enough to serve it, right? Okay, so how do you orchestrate all this? You need some kind of orchestrator. Of course, there's a lot of options here. I'm just listing a few that we've also considered: Talent, Matillion, Pentaho, data integration and data pipeline, etc., and DBT. Is anybody here using any of those? Which ones? Airflow? So who's using Airflow? Who's using anything else from that list? Talent also. Okay, I think Airflow is quite popular with developers because it's very easy to come up with out-of-the-box things, while the other more drag-and-drop style solutions are creating some limitations for you. Sorry? Mm-hmm. Yeah, so here, yeah, you're right, this is really about batch right now. NiFi, yeah, one of them, then Flink, there's other ones as well for real-time. For now, I'm kind of focusing on batch because that's where we got so far, but I will talk a little bit about real-time afterwards. But yeah, so here basically we have tools that are drag and drop, tools that are more developer friendly. Usually, you should check what the capabilities of the team are. If you're hiring more ETL developers who are more used to SQL but not to Python, then you use a drag and drop tool, and vice versa, etc. So this is it. Sometimes you might also have a different tool for operational data store, so like a data integration tool that just does the copy pasting here, and then a separate tool for managing the dimensional model, and then you might have another one for here. But what I think is a smart way to do is to put it all in one, because then it's easier to manage dependencies. So you can devise a system that basically triggers automatically when the data sources are loaded here, triggers the downstream pipeline, etc. Only if everything is in the same tool, of course. Or if you have a smart way of combining them. Now, when it comes to real-time, you basically have two options. I'm not going to go much into the details here, but I think it's quite familiar to anybody that's working in this, is that you have like the Lambda and the Kappa architecture. The main difference is, so it's not really either or, it's more like something that you can combine. But essentially the idea is that you can either compute a lot of the things in batch and then add on top the real-time data. So let's say if you want to say, I need to know how many sales this particular seller had up to the exact current moment. You might calculate the last 364 days in batch and then add another day or the current day in real time. That's a very simplified example, of course. But yeah, basically then you have two combinations, then you have to make sure that these two work together and that you can have the batch data available for stream computing, for maybe lookups, etc. And then here you have just pure streaming, so you sync everything. So you use a streaming tool. There's, of course, NiFi, Flink, Spark streaming, a lot of different tools. But yeah, different architecture, of course. Usually here, what you would also have in between is some kind of staging layer that can combine data that's available here with data that's available here. Okay? All right. So I'm not going to spend a lot of time on real-time this time, because we also don't have a lot of it, but happy to discuss it later during Q&A. For BI and visualization use cases, I just want to bring up a very small topic. How many of you work with BI tools, like Tableau, Click, other ones? Power BI? Yeah, quite a few. Okay, so I think the main difference between all the BI tools is either they work through some kind of in-memory layer or a cube. Like, for example, Click works like this. Power BI as well. Where basically you need to kind of sync or copy the data from your let's say, data warehouse into some in-memory staging layer, and then you build the visualizations on top of that. Or tools that work directly from the data warehouse. So, of course, the caveat on the right side is that your data warehouse has to be performant enough to handle this. So that brings us back to Snowflake or BigQuery. If you're paying per query, and the BI tool is not very good at caching things, then you might have cost, computing cost, every time somebody just refreshes a chart, right? And that can be very expensive, right? Especially if you have a lot of users. So yeah, here again, you need to think of a trade-off. Is my analytical database performant enough? Can I isolate these sometimes, very spike, characteristic of queries from the production things that are running on my analytical database? Is it, good enough to kind of like separate those workloads? If you are confident that you can do that, then it's probably better to go for that. Why? Because you're saving a data sync step, basically. So if you know how to update your data warehouse very quickly, maybe every 5 minutes or even every minute, then probably saving this step is going to save you a lot of grief because the users will be able to get more up-to-date data. Right? So who of you is using the left side approach in memory? Yeah? You happy with it? Not really? Okay, because you have probably a lot of logic in here as well, right? Yeah. Which tool? Okay. Okay. Understood. Yeah. Yeah. So then, what happens often is that you kind of, if the BI team is very separate from this team, you might have something like this happening inside your BI tool as well. Yeah. So you get basically this happening in here. Yeah. Okay. All right. Enough about that. So running out of time here. So I'm just gonna mention a few more points that I saw that were very interesting and might be useful. That are kind of more like bells and whistles on top of the data platform that you might, it might give you some ideas on what else you might want to add. I don't know where to start. Let's start from this side. So for example, it's very interesting to have a simple tool for monitoring your stability and sending alerts. So maybe something that you can just very simply say, okay, this table has to be updated at 9 a.m. every day, or at 5 past the full hour every hour, etc. And then if it's not, send some kind of alerts to the developer, etc. So that brings me back a little bit to the platform thinking. You don't want each use case team to have to develop these things, but rather have something that every team can just use without having to maintain the alerting tool itself, right? I mean, it's very easy to say, okay, we're using Airflow, so every developer can just put a piece of code in there to check the data, et cetera, but we usually see it's not very easy to expand that to everybody. Same for data quality. So you can say things like, how can we apply constraints and say, every day the number of rows in this table that are updated has to be within 5% of the number of rows that were updated yesterday, and then have a simple rule engine that you can just enter these things inside and make sure that it basically works and it will alert. And then you can have hard data controls that basically fail the pipeline if the data quality controls are not satisfied, or a more soft alert where the pipeline will finish, but it will just maybe notify the user that something is wrong. Having easy deployment and ops is very important. So for example, what I've seen also with Airflow is that sometimes you have a higher barrier to entry for new developers that join the team, because it doesn't really, it's slightly more difficult to develop inside a tool like this than it is in other tools. Yeah, so it's very good to have some kind of easy to use, easy to introduce system that if you just bring on a new team member, that they can very easily start doing things. Data labeling and anonymization. So if you're familiar with GDPR, this is becoming a very important topic, especially for the data platform. And you really want this to be kind of integrated inside. So the idea is that you have someone in the team who's basically just going, or like developing a system that detects personal data and labels it, and then a system that basically controls access, which is over here, to prevent people who are not supposed to get access to the data assets from getting it. And this can be also automated a lot. Like, for example, you could even develop a data science algorithm that automatically checks, does this look like a name, does it look like a surname or a phone number or address, et cetera, and then automatically label these things so that the developer doesn't need to worry about that. Metadata and lineage. So let's say that you are looking at a table here and you want to know where the data is coming from. wouldn't it be nice if you could just say, hey, where's this data coming from? And then it shows you the upstream tables, and you can click on this one again and shows you upstream ones again. I think this is a very useful thing because that also helps you with troubleshooting when there's an issue, etc. I've even seen, like, if a company, let's say, imagine that you have 1 million tables in your data platform, right? It can happen. How do you then, manage this, right? So then, if you don't have a metadata and lineage tool, you will be frozen for sure because you will spend too much time trying to, like, untangle the mess. Computing and storage capacity management. So in case when you need to, if you have the kind of architecture that needs to be upgraded, like Redshift, for example, or Snowflake, when you need to deploy more resources, it would be nice to have this in a way that's easy to manage, so without having to train people on the specific infrastructure that you're using, right? A data transfer capacity management, same thing for the network, and real-time collection for your database, so you can get all the updates on your database immediately. Yeah, these tools need to be compatible. Staging I mentioned before. Standardization, yeah, so naming convention I mentioned, and then the data model ideally should have a batch and a real-time version. Okay, that's it for now. A mandatory join us slide for those of you who are looking for work in Paris as well. Yeah, let me know if you're interested or send me an email. Yeah, that's it for me. Thanks.
Thank you very much. Сейчас у вас есть возможность задать вопросы спикеру. Есть ли уже у кого-то вопросы?
Hello, thank you for the great presentation. So my question is, what about the data lineage from your perspective? What particular granularity of data lineage in the metadata you need to be success with the data like analysis and so on and so forth for the troubleshooting and that's it. So whether the entity-based is really pretty enough or you need like a more granular one.
So you say, okay, I think, so what I've seen is a table-based, table-level lineage. Basically the way it works is you can have, for example, a parser that if all the data transformations are written in a language that you know, like SQL or something, you can just parse those queries and understand where the sources are automatically. And then this kind of tree can be built based on that. You can go even more granular, of course, but I think the initial one is at least to know on table level, right? And the benefit of this is, let's say that you have a tool that manages this very well, then let's say that you schedule a pipeline that takes data from 3 tables and then stores the result in a 4th one. This data lineage tool can detect that these are your sources and then immediately schedule your pipeline to run after the previous ones are done, right? So your lineage tool can also help you with orchestration, basically, or it can be integrated together.
So you can build a Airflow pipeline based on it and dynamically to build the DEX to use it.
Yeah, kind of like that. So ideally what I've seen, for example, work in some tools is that imagine the developer just writes a simple SQL query and just presses deploy and doesn't need to worry about scheduling or anything like that, right? Then the whole DAG is basically, like the whole data platform is like one big DAG, right? Effectively, yeah. I see a question in the back.
У нас еще один вопрос.
Thank you for the talk. In one of your slides, you mentioned that transactional databases and analytical databases are going to merge, and one database should emerge from this. Do you have maybe any concrete examples of analytical databases catching up to transactional? Because I see that tools like ClickHouse are built separately to manage analytical workloads, not transactional. So I see that separation is growing. And the only tool which fits both worlds, like Elasticsearch, has shortcomings both in transactional usage and in analytical. So maybe you have some examples of modern databases.
Yeah.
Like
To be honest, that was a little bit of my speculation. I don't see it happening yet. For sure, at the moment, still, these things are very separated. So yeah, you mentioned also Elasticsearch, which I think is also emerging as a pretty strong competitor to the analytical use cases as well. What I suspect is that's more likely to happen is actually that the transactional databases are becoming more and more performant in analyzing big data sets. And what might happen, again, a speculation, is that they can enter this space as well, rather than the other way around. But again, a speculation, right? It's something that I think is just interesting for any architect to think about, because if this actually happens, that would have a huge impact on the way you design your data platform, right? Because then you might not need to have a completely separate system at all anymore, right? So I think it's something worth observing and always checking how these systems perform, rather than just being entrenched in the mentality that you need a separate system, right? But yeah, I mean, right now I don't have a concrete example. I've seen, for example, previously we were using Hadoop. Of course, this one is nowhere close to being, transactional or being able to do anything row-based, right? It was very, specific for big data volumes. But now, when it gets to Redshift, you can already update individual rows. You can, okay, it takes maybe a few seconds rather than a few milliseconds. But if I extrapolate this trend and expect that this will get more and more performant, maybe at some point the analytical database will be just good enough, right, to do some basic transactional use cases.
Все, больше нет вопросов? Последний вопрос.
Hi, thanks. Great topic. I have a question regarding the data lake. You didn't mention it here in the schema, but what I see recently, and actually we're trying to do it to embed and use data lake as a part of our data platform. How would you position the data lake in those?
Okay, it's gone. I would actually say that maybe the data lake is the operational data store that I had in the bottom can be kind of can be exchanged basically by a data lake, right? So I've seen, I think, for example, you could also design an architecture where the operational data store is not in the same infrastructure as the common data model. So, for example, you could sync all your data into an S3 bucket or in some other storage, and then, or in Hadoop or whatever, and then just the data that's made available to other users actually goes into the data warehouse architecture. So you could actually decouple that 3-layer into 1+2 kind of. And then again, if you have a very performant tool above your data warehouse, maybe the application data store can also be decoupled from the data warehouse. But so far what I've seen is, ideally you want to have everything together, because sometimes you're just going to want to do a join between something that's in an operational data store and something that it's in CDM. And if it's separate, then you have another step to perform, right? Yeah. Okay.
Okay, thank you very much.
All right. Thanks for your attention.
Поблагодарим Александра.
Yes.